Hello, folks, and welcome to the Embedded SIG meeting for the 21st if you're in the US and the 22nd if you're in Asia of the US Asia Embedded Special Interest Group meeting. I don't know, Luke, were you in the last call? I wasn't. Normally just double check to see if there was anybody in the last call who would like to give us an update what was discussed. Going once, going twice. Don't see one. So last time I was on an EC call, I had the to-do task of translating some wish list items that we had into something that looked more like a structured plan and document outlining what a long-term support version of WASI would look like for the embedded community. And I went through and did that. So this whole discussion today is essentially going to be a request for your support to read the document and for folks to comment on it and tell me what you think. It's on a Google document, and I will share the link in the meeting notes, and I'll also paste it here when I find the chat button. There we go. It's here. So what I'll do today is just go through the wish list and how we translated it. Not everybody agrees on this. It is not final. It is up for discussion. Everybody's view is the same, but this carries the same weight. If you don't agree with something, just shout or let me know or contribute to the discussion, and we can talk it through and see what we can get to. And this is, like I say, the first call of it. What I'll do now is I'll just share my screen so I can talk you through the wish list and the document that we have and give you the highlights. And that should get us most of the way there. So next bit, how do I share? I want to share this brainstorm list. Here we go. Okay. Quick question for everybody. Can you see my screen? Somebody say yes.
Yes.
Awesome.
Yeah.
Great. So the bottom of this was the original brainstorm list. We had loads of open questions about what do we mean by an LTS, what features are going to be included, time frame and duration, basically everything you can see here. So it was everything from like, what does it really mean? Concretely, it sounds like a great idea in theory, but pen to paper, what do you actually need? What are going to be the real deliverables on which operating systems, and what might it look like? There was a suggestion that we could provide tier 1 and tier 2 support for certain platforms, which you will see that I didn't pick up on yet, or at least in my translation of this wish list, I didn't follow up on it. Then I went through execution environments and development environments, and I pulled those out. There was comments on, well, if it's an open source project, then what do our coding standards look like? What do we need to do for that? And that was a really interesting problem too. And I think David from the Bytecode Alliance, he did a lot of work digging out policies from the Bytecode Alliance for that too, which was really good. And then how do we address problems, conflicts, make decisions and priorities? So there was a request for down here for kind of like guiding principles and rules that would give us the guide on how do we approach a problem or a conflict. What would be the guiding rules we should follow to help us make those decisions? And then there is this open question about how to achieve compatibility with P2, P3, and eventually version 1. So that is about it, I think, for the wish list items. Now, I went through this and I said last time I was on the call, I would go through and just give kind of an opinionated version. Doesn't mean my opinion's right. My opinion is often wrong. Reason for me doing that is it's often easier to disagree and have a constructive conversation when somebody writes it down. So that's all I'm doing. Like, oh, well, this obviously means this. And I write it down in an effort to get people to say, oh, I don't agree with that. I would like that changed. So it is not, like I say, these are all work in progress concepts you're welcome to look at. If you go to the top of the document, you will see what we're trying to do. The intended audience is basically us and the various stakeholders and participants in LTS to find a common viewpoint and direction of travel. So basically, it's just translating that wish list into something a bit more structured. And so far, I got 10 pages out of it, which are mainly all text. So why are we going to do it? So here I'm trying to outline why we would have an LTS. What are the key benefits? And things that we were looking to address was to make sure that a compiler and at least one, if not two runtimes, could work together. So our compiler and toolchain would produce code that the runtimes we're using in our LTS project will be able to use, and that will stay compatible for the lifetime of the LTS. And I said, based on Marston's comments, he said he really needs 7 years, which would be great for us too. So I just put 7 in there as an example. So the key benefits is to always ensure that the output of the compiler and toolchain will work on the supported runtimes. There are no change to command line or build or link switches. Because in the past, we've had situations where the compiler and the toolchain get updated to include some of the latest features, and it breaks existing runtimes. Because the default output of the compiler changes. So here we're saying, don't change the default output because we've got legacy runtimes. And this would imply that if new features come along, then at least for the LTS version, for the lifetime of that LTS version, they wouldn't be enabled by default, but could be enabled by an additional switch or command line parameter added to the compiler or the linker. So that's essentially what we're saying, is just keep everything working. And this will ensure that CI/CD pipelines built on LTS will continue to pass and work, and that new features won't cause them to stumble. So software portability is the next thing we looked at. Because just as WebAssembly in the web is really popular because it allows people to take code for non-web platforms and bring it to the web, that's one of the cool advantages of WebAssembly in the embedded space. We're often trying to take code from more advanced systems and put it and make it run on a smaller embedded system or on a real-time operating system, even though that piece of software has come from traditionally Linux. And if we can make that porting process easier, that would be good for the WebAssembly community in the embedded space and the LTS WebAssembly platform. So then we got to some key principles, which were really simply, and I won't go into lots of depth here because you can totally read it, but if you have any questions, shout. Basically, don't break the runtime, and I've just covered that. So then if we discover a bug that's going to cause the LTS to just not work at all, or a feature that we've not implemented the way we wanted to, or we inherited and it's not great, as long as it's not causing a huge break in security or stability, then we just learn from it and fix it in the next release. And this is just essentially to provide stability. And then because we're in a situation where P1 has been deployed in production already, then the next step is be practical over perfection. There are limitations imposed by P1. There are things that have gone out in the field already, and we have to be practical about it. So don't labor over those issues too much, and do a practical next step. Then platform portability is an aspiration, not a destination. And this is kind of in line with practicality over perfection, because the embedded platform space is so big and there are so many different devices that qualify. It's obvious that not every piece of software can run on every platform, every piece of hardware, or every piece of hardware and OS. It just doesn't work that way. And this is particularly if we need to add additional functions to support code portability, then do it with the idea that not every platform is going to have every interface, and work on that basis. And the next thing, and this comes down to the coding guidelines, which you'll see coming up. And it came in the wish list, is work with the parent projects. And actually, when you look at what LTS would probably become, if it's a stable version of WAMR and a stable version of WASM2C, and what we regard as a stable version of P1 WASI, then, well, they're parent projects. So let's work with them. We don't work against them. If we've got a change and we think it's good, and we're adding code, even if it's in our own repository, to our own versions of those projects, then we follow those projects' coding guidelines and styles and best practice. Why we do this is because ultimately we want the code that we maintain in our project and the LTS project to be as small as possible. And we actually do want to upstream whatever we've done. So if we've made a change to WAMR, which helps its stability or adds a feature that everybody wants, we should contribute it back to the parent project. And certainly likewise with WASI Preview 1. If we've done something there that makes sense, just contribute it back to the parent project. As long as the parent project's happy with that, of course. But that should be the goal. So the motivation for long-term support, and this calls out some of the problems, and you can see there's already some comments in here. I'm not going to go through the comments because I'm going to encourage you to do that yourself and add your own views on it. But I'll just explain this bit, why it's written. So the motivation is just going through why we need this again, answering that question of why an LTS. What's it going to offer? Or what problems that we see? And obviously one is, well, we need it because there's a large installed base of Preview 1 users already. And then I've already covered this stable synchronized tool chains and runtime, so everything works. And then some more details around assisting software porting. So you can see folks are starting to comment on what does it really mean to have a pragmatic way. So that's it. So then if we're going to have synchronized tool chains and runtimes, what does it mean? Is that, well, if you add, things get out of sync if you've got a pre-built WASI libc, which has built with some of the latest new WASM core instructions by default, but we've got a runtime that doesn't support that. So that would get it out of sync. So everything, including what the compiler produces and how the WASI libc is built, would have to be all in sync. So this is just kind of pointing out that synchronization isn't just between the compiler and the runtime, but it's between the compiler and WASI libc and the runtime, and the three have to be in sync. Then it goes through what do we mean by supported runtime, and we said WASI, we said WAMR, and we said WASM2C is the two supported runtimes. And then that gives us a list of stuff we want to support. And Marcin's asked for Rust support to be added. That was in a discussion that happened a couple of hours ago, I think, last week or very, very recently. Support platform suites runtime. So here's just a table. And essentially this table has been built up from the stakeholders who want the LTS, saying, well, I want the LTS and I think I'd like it on these platforms. And that's it. There's no other justification or thinking that's gone into this, just those folks who would like to contribute to LTS, what do you need out of it? And this is essentially us looking at what's the minimum possible set of platforms we would have to support. And that's essentially, it's not that it wouldn't work on the other platforms, we just wouldn't put any of the CI/CD testing and framework and validation in place to make sure that we do. So it would be best effort for those. There's no mention of tier 1 and tier 2 in this document, and that concept that Stephen suggested is good, but I just didn't put it in. Yeah. So certainly room for that too. And that's for the runtimes. And I guess you could call this the execution environments. The next bit is the platforms upon which our tooling works. So would it be Windows ARM64 or just x86 64? More about Mac OS and more about Linux. So this is us just sketching it out, and you can see, and this is where your feedback is really important, is you can see us discussing, well, exactly what platforms is it that people needed and what does that look like? For assisted software porting, that's where we go, okay, we're going to bring in this POSIX-like interface, POSIX-like libc-like interface to help support software that's been written on Linux to run on top of WAML and WASM-C in an embedded space. What would that look like? So that's the next bit we started to think about. And for that, it's, well, there's inspiration from Wally. We're not saying take Wally, but we're like, hey, we got this large syscall interface working. That was kind of cool. Aid soft reporting is not perfect. And we call out some of the stuff that's wrong with it. And we say, well, hey, what could we do? Could we use this as inspiration and just say, well, Linux has a kind of good system interface. If you had a decision between implementing different platform APIs, what would you do? Well, just enter in. Could you just use Wally and a syscall as the basis for, or Linux syscall as the basis for it? Which would imply that that syscall-like interface would be ported to other operating systems and runtime environments, which is the next logical outcome of that. So that's what it says. So that's it. And then some guidance. So this is where we say, yeah, just use, where possible, use the function that's already added and mimic. You can make, could you mimic the Linux syscall interface? Would it be perfect on every platform? No, but practical guide. You know, platform portability is an aspiration, not a destination. Would it be good enough? So that's the sort of stuff we start to bring up here. And again, this is just for discussion. So future migration to the component model. So it is the intention that Preview 1 LTS will migrate using the component model for ABI implementations. So even if we've got a syscall interface, hey, we could implement it using a component model. And I even believe that Wally, I saw a Wally issue saying, could we have a WIT for Wally? So that looks like a possible way to go. And then you can see discussions about what that would mean realistically in the document. And then what does this mean from a practical point of view for the LTS? Well, essentially it becomes like a downstream fork or a downstream version of all of the artifacts that we want to support. And all we're doing is putting the CI/CD pipelines and verification in place to make sure that we keep the synchronization between the WASI libc, the compiler output, and the runtime. And that's probably going to mean reworking some switches potentially as new features get added and we want to support them, working out which features we do want to support and if there's demand for it. That's what it's going to be. Most of the work is going to be doing that. And then if we do add any portability features, it's working with the upstream projects. So if we add something and it makes sense, then contribute it back upstream. So this is essentially what we're trying to do. And here you see me outline what verification is and what we would check, how it would work, and then getting through to define what a release definition looks like. And that kind of gets us to the bottom of the document. And I've talked for a long time and gone through all of that rather quickly. But that is essentially it. And it is an interpretation of those wish lists. And it's just my initial interpretation of these wish lists, which does not make it accurate, which is why there's lots of comments on the side and me trying to explain what I'm thinking and admitting that I am confused on some points and just made a call. So that's it. I would encourage you to take a look at the document and add your comments to the Git document, to the Google document, if you could, on what you think. If there's something you agree with, let us know. If there's something you vehemently disagree with or you think could be done better, please add it to the document and we'll try and iterate on it. But this is just the very first version with the very first outline and kind of shows you, I mean, from this, you can see we're going to need a CI/CD pipeline and it gives you an idea of sort of the effort that would be required from a developer contribution point of view from each of the stakeholders. And we can kind of derive a lot of that from this document. And that's kind of why it's there. Any questions? Awesome. Any initial, oh my gosh, I wish they didn't write that. This is where I look terrified. No? Okay. Any like, hey, that was awesome. I like that. Silence.
Yeah, it is awesome. I'm first time first meeting here. I'm interested in a lot of WAS. I'm actually not knowledgeable about this area yet. So I'm just curious. Is this I have some questions about when it comes to security. Is this the right meeting to ask those questions, or there are different meeting?
You most certainly could ask those questions. I don't know if you get the right answer, but you feel free to ask them. If not, I'm more than happy to help redirect you to folks who can answer it in a bit more detail.
Yeah. One is I know WebAssembly is known for to be very secure, and there's actually a question came up about how is there any like formal testing to test whether a distribution is actually it is secure as it claimed to be?
That's a really good question. Luke, do you know of any?
Well, I guess for starters, there's definitely fuzzing that's used and applied to some of the runtimes. You know, fuzzing doesn't catch all possible bugs, but it certainly catches like, especially like low-level implementation things where, you know, you can break out of the sandbox. So that's one category. But in addition to like the WASM runtime, then you might also want to be able to exhaustively test the system call interface, things like, you know, the WASI surface area. And I'm not sure if anyone is fuzzing that, but anyways, fuzzing's a big part of how we develop these runtimes.
So would you would say fuzzing equal to formal analysis, formal testing?
Oh, no, I guess they're complementary approaches. You know, a formal analysis might try to catch problems, you know, kind of without having to run the code. And so, you know, maybe be able to prove whole categories of errors don't exist. So it's more work and but a stronger outcome or a stronger guarantee. Fuzzing is a good complement for that, for maybe things that are hard to formalize. Um, and yeah, so I've seen both techniques used. Actually, there are parts of some of the engines that are formalized. I can find a link that discusses a lot of these in the meantime and drop it in the chat.
Yeah, that would be great. That's one. Other is, I know WASM is mostly for edge use cases, maybe not completely, but edge use cases is definitely big, and also there are a lot of like agentic AI, if you will, use cases. So, which use group, which group typically discuss about topic like that?
To repeat that one for me.
Oh, for just discussing about different use cases. So, I'm not sure because Bytecode Alliance, how do you group the effort? What's the scope, other than spec itself? Anything specific about use cases and like security and edge use cases, edge computing use cases versus data center use cases, and then any AI use cases. Is that in scope for Bytecode Alliance?
Yes, in part, yes. Although I think the use cases are defined a little bit less vertically. So there is WASI, which gives us system interfaces, but then there are extensions to it for interfaces which are more appropriate to, say, cloud edge rather than data center, or more appropriate to data center than embedded. So you get use case definitions. The Bytecode Alliance is mainly focused on the system interfaces. So it's the APIs to talk to the system or to talk to other pieces of software, all done through WASI. And then it kind of goes through some use cases and defines APIs for those use cases. So there is WASI NN, or WASI neural networks, which describes AI use cases with a predefined API. So that's one. And there is a a group that meets to discuss that. Then there is other groups that meet to discuss things like database interfaces and HTTP interfaces, and what they look like, which is different from the POSIX-like interfaces that we end up talking about a lot in the embedded special interest group. So
the actual security and actual use cases I guess probably is actually discussing each implementation's community, right?
yeah, you can discuss it with each implementation, but you can also discuss it with the core WebAssembly group. So the way it's kind of structured is we have core WebAssembly, which is done in the W3C as well, and that's the W3C community group. And its parent is the working group, and Luke's co-chair of that working group. So they focus on the core WebAssembly specifications. That's like the bytecode that gets interpreted, and there's a whole lot of formalization around that via the spec tech format. So you have this formalized DSL for defining core WebAssembly, and that's done at that's kind of heart of WebAssembly essentially. It's called WASM-bit, and that group has a lot of people who are very interested in the formalization and what you can do with it, and could you use that for testing and validation, and what would that look like? Could you use it for creating ultimately a completely formally verified runtime or completely formally verified WebAssembly compiler? So that's the core WebAssembly bit. But core WebAssembly by itself, as you might see mentioned in some of the documentation, online videos, I'll say it's basically just a calculator. You can calculate stuff, but it has no access to the outside world. And to get access to the outside world, it needs a system interface. And then this WASI groups basically drive most of that sort of system interface discussion. That's also part of the W3C. And then that's essentially where most of the Bytecode Alliance's interest is doing implementations for and driving an implementation of that. So that's how the structure works. It's a bit, I know when I first stumbled across it, it feels a little bit disjointed. There's little bits everywhere, but would recommend if you're interested in the security side and the formal spec tech stuff, the great community in the community group of the W3C to join. You can, certainly there'll be a lot of people really interested to talk to you about that. And then in the more system interface side, which you would want from a security and sandboxing point of view, that's more of the Bytecode Alliance and more of the WASI subgroup. Did that help?
Yes, yeah, thank you.
And did I get it right, Luke? Did I miss anything?
That was great. No, it's a lot to cover. So, good job.
Yeah.
I'm
Cool.
gonna just put a link in the chat of the post I remembered.
Thank you very much. So, Victor, I don't know if you've joined the WebAssembly community group yet, or
Yeah, I'm in the CNCF channel. I think it's paused for some reason, right? There's no activity right now recently.
yeah, let me. Well, Victor, if you want to send me your email address for a private chat on here, you don't have to give it to everybody. I can follow up with you, make sure you get the right links to all the stuff, give you introductions to the co-chairs of the community group too.
Yeah, I don't have a problem. I can share my email here.
It's Conrad and Thomas, is it at the moment? I think it is. Cool. Then I will do a quick intro with you and those folks to get you all kicked off and make sure you're signed up and have the meeting invites for the community group as well. That'd be really cool.
Awesome. Thank you.
No problem at all. It's part of what we're here for, is to make sure people get the right connections. Okay, so any other questions? Nope. Okie dokie. In that case, I have an email to write. But in the meantime, have a fantastic evening. Please do take a look at the LTS document. It would be fantastic to know what you think. Agree with, don't agree with. One of the questions that did come up in the LTS was folks, there's a discussion you'll see where folks are asking for more detail around how do we eventually get to using the component model, and what would that mean? And then there's some discussion about that. There's nothing written down there yet that says definitely this or that. It's just a discussion. The aspiration remains to move to the component model. Once it's usable in the embedded devices, and I guess the next question you can see in the discussion as well, we should define what that usability is. Essentially provide like the quality gate for that, to say once this is met, then we need to reevaluate what we're doing and move towards it. So bits and pieces like that are coming out, which is good. Gives some concrete deliverables that we have to achieve, and we can put those into this LTS document too, along with the artifacts that we would need to support. So please do take a look at it. I would really love your value and really love and value your input and your thoughts. In the meantime, have a fantastic couple of weeks, and I guess I will be back in 2 weeks' time. Let's find the stop recording button.